Hello and welcome to our group's final project. We are going to be talking about homicide rates in the state of Massachusetts.
Okay, so our research question. We want to know if there's a relationship between age and homicide death rates, and we want to do this while accounting for gender and marital status. So essentially, we'll be looking at the relationships of all three variables with homicide rate. We actually expect that all of the three variables will show statistical significance, and we think that our data will show that young, single, and male are going to be the most likely demographics to be homicide victims.
To test this, we used a dataset of individual birth and death records. The data that we use is anonymized and publicly available, so there are no really big privacy concerns. Furthermore, there are no personally identifying characteristics in our dataset. But that said, there are still some limitations like potential biases in how our data was collected or cleaned, and our conclusions are specific to Massachusetts.
Our background research shows that homicide death rates are not equal between demographics. Paula Strassel's research concluded that men under 45 are most likely to be victims of homicide. Kapaswa, Singh, and Brialt found that unmarried men had significantly higher homicide risk compared to married men, which they linked to lower levels of social integration. Kapaswa also found that women's marital status had a strong yet complex relationship with homicide rates, with divorced women being most likely to be victims, widows being least likely, and married and single women having similar likelihood to be homicide victims. This gives us a strong foundation and good reason to go with age, gender, and marital status as our variables. For the first part of our data analysis, we're going to do some visual inspection. We aren't necessarily drawing any conclusions about our predictor variables yet. We just want to get an idea of what our data distributions look like. We can see that non-homicide deaths tend to follow a pretty natural pattern. The older the age group, the higher the death proportion. On the other hand, homicide deaths show a completely different pattern, with the death proportion peaking in the 19 to 25 age range. Okay, let's see how control of variables affects our data. So with a little bit of editing magic, our histogram is now grouped by gender. The regular deaths seem not to differ much by gender, and generally each group looks the same. On the other hand, we can see some interesting differences in the homicide histogram, which is suggesting that women have a much lower victim rate. Remember also that D is our decline to answer category, and from the looks of it, it seems to be fairly similar to the male grouping. Now, instead of gender, let's group by marital status, using a little more magic.
By marital status, regular deaths skew older for married and widowed groups, while homicides are more common among single individuals, especially younger people. This suggests that marital status might be related to the observed patterns, although it might also be related to age, because younger people probably aren't married as much. And these box plots show homicide victims are generally younger. Single individuals also tend to be younger, while widowed individuals are older. Non-homicide deaths are mostly older overall. This reinforces our earlier observations.
Okay, for the meat of our data analysis, we did a logistic regression because this works well with our mostly categorical variables. Looking at the regression shows that almost all values had a strong statistical significance compared to their baseline group. The only exception was our gender D category, which did not have a significant difference to the baseline male category. However, our model is spinning a warning for possible quasi-separation. That's a lot of big words, but here's a quick breakdown. Our model is looking at many different combinations of our three variables. This creates many different groupings of different combinations, but not all groupings are equal. For example, there might be 20,000 married 27-year-old men in our dataset, but there would obviously be far fewer 10-year-old divorced men. There are over 1,000 possible combinations, and some categories might be exceedingly rare. If the model only encounters one 10-year-old divorced man who might have tragically happened to be a homicide victim, it might begin to strongly associate 10-year-olds with homicide and begin pushing its coefficients towards infinities in order to achieve the best chance of predicting these categories. While it manages to create a strong regression here, this might not generalize well. This is an example of overfitting, where the regression could be learning noise in the data rather than actual patterns. The good news is that we managed to lower the perfect prediction to a reasonable rate of 0.1, but it's still worth keeping in mind and still could be messing up our results. That being said, the ratios of our regression show that the model predicts that for each additional year of age, likelihood of being a homicide victim decreases by almost 8%, and a woman is 59% less likely to be a homicide victim than a man. Being single shows a whopping 89% increase in chance of being a homicide victim in comparison to being married, while being divorced or widowed shows a 21% decrease. This model shows that about 31% of our data is explained by three variables. Finally, let's do some individual regressions to see which variables contribute most to the explanatory power. We see that age by itself has an explanatory power of 30%, which is almost just as good as the 31% with all three variables. Marital status shows a respectable 12% explanatory power of our data variance, but when combined with age, it takes age from 30% to just 31%. This indicates that age and marital status are likely very correlated. Duh, and it's actually not that helpful to use both age and marital status rather than just one. Gender showed an R squared of just over 1%, suggesting that gender by itself has a very low explanatory power. This seems paradoxical because we saw big changes in homicide rates in different gender groups, as well as strong statistical significance, but this is just telling us that gender by itself would not be a good predictor for homicide.
In conclusion, our analysis shows that homicide patterns differ from overall mortality in Massachusetts, who passed away from 1999 to 2024. We observed that homicide cases are more concentrated among younger individuals, males, and those who are single. It's important to know that we're not making predictions, but rather identifying patterns present in this data set. And thank you for listening.